Inside logistic regression, I have project 1. Let's click on this project to open it in our Google Colab environment. So this project has opened in Google Colab environment. So for this project, I need NumPy, I need pandas, and I have to import logistic regression from sk.learn_model. So let's run this cell to import all these necessary Python libraries. So the next step is to generate the data. So here I am generating a data. Basically, I am generating 12 samples of a data. So I have X, which is feature, and I have Y, which is target variable. If we see that the first 6 values of the target variable are 0, and the last 6 values are 1. So we have 12 samples, out of which first 6 samples belongs to class 0, and the last 6 sample belongs to class 1. Now, what this data is about? So basically, in this data, every value is the size of tumor in a patient. And with respect to size, we have assigned a label 0 or 1 to the patient. So this 3.77 is the size of a tumor of a patient. This 2.47 is also a size of a tumor of a patient. So here is the explanation of the data. X is the size of tumor. Labels are 0 or 1. 0 means no cancer and 1 means cancer. So the label 0 assigning to the patient, showing that this patient doesn't have any cancer, and 1 means cancer. Now let's change this data into a data frame so that we can understand it more clearly. So in order to convert the data into the data frames, I am using the function pd.dataframe. The first column is X, and in that column, I am passing the value of X. The name of second column is Y, and I am passing the value of Y in order to generate this data frame. So let's run this cell. We can see that the name X is not defined. So basically, first we have to run this cell, and now we can run this cell. Now we have X. We have 12 values for X from 0 to 11. We have 12 values, and we have 12 values for Y, and first 6 values are 0. It means if the size of a tumor in a patient is 3.77, it doesn't have cancer. On the other hand, if the size is around 6, it has a cancer. So 1 represent cancer presence and 0 represent the cancer is not present. Now it's time to apply logistic regression model on this dataset. That is to train the logistic regression model on our dataset. So the first step is, here I am instantiating this logistic regression because you see here, I have already imported it before. Now here I have instantiate the logistic regression, and I am called the variable as log_reg. Here I am fitting this variable to my data X and Y, and I am saving this into a variable LR, which is a logistic regression variable. Now let's run this cell. We have fit the data, but we get the error. Now what is the error? So error is telling that they are expecting 2D array, and we have 1D array instead. So what to do? So we have to, they are suggesting that you have to reshape data using -1 +1 in order to transform 1D into 2D. So they are saying that for logistic regression, we need to transform our X into 2D. So this is a requirement in Python for the logistic regression function. So let's check the shape or the dimension of our X. So X.shape here X is 12. So it is 1D. Now it's time to transform into 2D so that we can run it into a logistic regression function. So for transforming, we have to use X shape, reshape, X.reshape, and we have to use -1, 1. By doing this, I have transformed this X into 2D. Let's see X now. If I want to see X here, now we can see that X is in the form of column, and now it is in 2D, and we can also confirm it by again observing the shape of this X. So if I observe the shape of this X, we can see that now it is 12 by 1. It has 2 dimensions, that is 12 and 1. So we have transformed 1D X into a 2D X using a function reshape, and we are passing the inputs -1 and 1. Now it is in the format which required for the logistic regression function. Let's run this cell now, and we can see that we did not get any error. So the model has been trained on the dataset which has only 12 samples. Now it's time for testing the model and to get the probabilities and to get the prediction. Now, in order to test the model, I am generating a simple sample, only one sample, and the value of sample is 3.5. And here I am reshaping it so that I can pass it to the logistic regression model. We have seen that the requirement is to reshape the samples. Now, this is my unseen value. This is a single test sample. Now, click on this in order to generate the sample. And here I am getting the predictions from my linear regression model that what is the probability that the given sample belongs to class 0 and class 1. If we go back, we can see that we have two classes, class 0 and 1. 0 means no cancer and 1 means cancer. Okay. Now it's time to get the probabilities. So the function is LR, which is linear regression model dot predict underscore prob A. That is the probability, the short form probability. And here I am passing my test sample. Let's run this cell to get the predictions. Now you can see that we are getting two values of probability, 0.54 and 0.45886. If I add them, they will be equal to 1. Now what this model is suggesting, the model is saying that it is highly likely that our test sample belongs to class 0 because its probability with class 0 is higher than with class 1. Let's confirm this by calling the function lr.predict and check the prediction. So here we are getting the label from the model and we are passing our test sample. Let's see the predicted label. So the predicted label is 0, which is in accordance with the probabilities. It means our logistic regression has produced correct values of the probabilities for both class 0 and class 1. So the probability of this test sample is high with class 0. Therefore, this test sample belongs to class 0. And we have confirmed this with this calculation that it belongs to class 0. So the sample value is 3.5. If we go back, there is no 3.5 in our data set. But if we see this 3.5 is between 3.7 and 2.4, it means its value is in between and its label should also be 0, which is verified by calculating the probabilities and also by getting the predictions. So in this way, in this lecture, we learn how to find the probabilities of a test sample using the logistic regression, and from the probability how to decide that which class this sample belongs to, and then we will confirm by calculating the class predictions. So I stop this lecture here and I will continue this project in the next lecture. See you there.